to record. All right, so under lecture 3, I want us to start a new subtopic, which is sets of numbers. So we're still under sets, but in this case, we're just going to look at numbers. Yeah, so the first thing that we're going to start with is defining the types of numbers. And after defining the types of numbers, we're going to proceed to look at individual. We're going to pick out some of the numbers that are a bit new to most of you. Yeah, so we know what odd numbers are, what natural numbers are, but we're going to do a quick recap on those, and then we're specifically going to pick out some sets of numbers which we're going to discuss as a subtopic as well. Yeah, numbers like rational numbers and irrational numbers. Okay, so let us quickly see what we have for tonight. Okay. Let me just connect my tablet. Okay, and then don't worry about assignment 2. I'll start working on it this week. So I think by the end of next week, I'm supposed to be done. Okay, so let's continue. So we'll start first by discussing the types of numbers, like I said. So under the types of numbers, the first set of numbers that we're going to discuss are what are known as the even numbers. So the simplest definition of even numbers is all numbers that end with 0. So any number that ends with 0, 2, 4, 6, and 8 is known as what? An even number. So under the same course, we're also going to look at what even functions are and what odd functions are, and how to determine what an even function, or how to know whether this or any given function is even or odd. So we're going to look at that as we progress. Yeah, so any number that ends with 0, 2, 4, 6, or 8 is called an even number. And then the other definition of even numbers is any number that is divisible by 2. So when you divide 0 by 2, the answer that you're going to get is 0. When you divide 2 by 2, the answer is 1. When you divide 4 by 2, the answer is 2. When you divide 3 by 2, the answer is 3. When you divide 8 by 2, the answer is 4. When you divide 10 by 2, the answer is 5. So any number that is divisible by 2, or any number where 2 can go in without leaving any remainder, is known as an even number. So let us look at another set of numbers. So we also have another set which is which is odd numbers. So odd numbers are like we defined. Okay, there are what I can say about odd numbers is that if you have, okay, let me just give you a simplest definition. I wanted to talk about something. Okay, the simplest definition of odd numbers is any number that ends with either 1 or 3 or 5 or 7 or 9, or any number that ends with these numbers is called an odd number. And then the other definition of odd numbers is that any number that when divided by 2, it gives a remainder 1. When you divide any odd number, it will give you a remainder 1. I mean, when you divide any odd number by 2, you always have to get a remainder 1. So any number that when divided by 2, which gives a remainder 1, is called an odd number. So that is exactly what an odd number is. And some of the examples are here. Okay. Let us also look at another set of numbers. So this set of numbers is called the set of complex numbers. So for complex numbers here, I'm just going to introduce them, but there is a topic, it's a topic on its own. Like I said, some of these numbers, we're going to pick them out and discuss them individually. So um, for complex numbers, I'm just going to introduce them to you, but there will come a time when we're going to discuss this as a okay. So let me just mute everyone. Okay. So a complex number is any number that is in the form a plus bi. So in some books they use j, in other books they use I. All right. So sometimes it may not be defined by a and b. Sometimes they can use z. So sometimes they can use x and y. So any number that is in form of this, then any number that is in form of this is called a complex number. So some in most of the books, or let me say, it's usually denoted by z. It says z is equal to that. So when you say z is equal to that, it means that this z is a complex number, because we have the real part there and the complex part. So when you have a complex number, which is, let's say you have z is equal to a plus bi. This part here is known as the real part of the complex number. And then this part here is known as the imaginary part of the complex number z. Okay. So for instance, if you have, let's say you have z is equal to, maybe you have 1 plus 3i. So this part here, this one is known as the real part of the complex number. And then this 3 there is known as the imaginary part of the complex number z. Okay. So this is what you should understand. Now, I know one of you might be asking themselves, what is this I? Or what does this represent? So I is simply just equal to the square root of -1. So I'm sure some of you who have done, okay, let me say everyone here have solved a quadratic equation before. There are some equations that cannot be factorized. Rather, there are some equations that have imaginary roots. Yeah, so I'm sure if you have not learned about roots of quadratic equations, we are going to learn them as we progress. There's a topic there, there's a topic ahead of us where we need to discuss that. So there are some equations that have imaginary roots. That's where maybe you find, after solving an equation, you find at one point maybe you have the square root of -25. When you have the square root of -25, we use to say this is this has no solutions. We say the quadratic equation has no solutions. But if you have learned complex numbers, the square root of -5 is easy to find. So we know to say I is equal to the square root of -1. So when we say I squared will be the square root of -1 squared. So this square and that will cancel, meaning the answer is -1. So this tells us to say I squared is equal to what? -1. I'm sure one of you, Cynthia, was asking to say, I think there was a part which I don't know if she got confused in an assignment. She said, why do we have that? I don't know the question that she asked, but it was based on this same I. So this is where now you need to know to say I squared is equal to -1, because I is equal to the square root of -1. So if we say 2i times 3i, the answer is what? Is -6. And the reason why we're saying it's -6 is because we are going to have 2 times 3 there to give us what? 6. But because I times I is going to give us I squared, the answer we're going to have will be 6. Then I squared we have said is what? It's -1. So we put -1 there. When we multiply, the answer will be -6. So that is how you deal with complex numbers. So this is just an introduction of complex numbers. Like I said, I'm just going to do a brief introduction to all the sets of real numbers. Of course, maybe we may not discuss all of them, but at least we'll tackle those that are important to this course. Okay, so we're going to discuss complex numbers later in details. So let us also look at what prime numbers are. So prime numbers are simply just numbers with only two factors. And these two factors are 1 and itself. And the smallest prime number that we have is what? Is 2. So the smallest prime number that we have is 2. And then we continue going like that. So any number that only has two factors is known as what? A prime number. So 9 is not a prime number because 9 has about 3 factors. We have 1 can go into 9, we have 3 can go into 9, and 9 itself can go into 9. But when you look at these other numbers that I've written this side, they only have 2 factors, 1 and itself. Okay, so that is what we call, this is how you define prime numbers. So I'm going to send you the lecture slide in case you want to go through the notes. So we also have another set of numbers that are known as the set of natural numbers. So natural numbers are simply just counting numbers starting from 1 up to positive infinity. So whenever you're counting, if you start with 1, 2, 3, going up, so this means that you're counting using what? Natural numbers. So once you just add a 0, then it becomes something else. Okay, once you start from 0, it becomes something else, which we're going to discuss. So natural numbers are simply just counting numbers starting from 1. Yeah, so natural numbers only consist of positive integers. So it's rare to find a negative number as a member of a set of natural numbers. So negative numbers are not natural numbers. So this is the reason why we call natural numbers sometimes as positive integers. So these are just counting numbers starting from 1. Okay, let's also look at what whole numbers are. So whenever you're counting and you start from 0, it means that you are counting using what? Whole numbers. So a set of all natural numbers plus 0, or adding 0 to that set, it makes what? A set of whole numbers. So when you add 0 to the set of natural numbers, the set that you are going to have is going to be called the set of whole numbers. So the set of natural numbers, when you just add a 0 in front there, means that you have the set of whole numbers. Let us also look at integers. So integers are simply just whole numbers, both positive and negative. So when you get this same set of whole numbers, and then you also add another set of whole numbers which are negative, you come up with a set known as the set of the set of integers. So integers are simply just positive and negative whole numbers. So when you add a set of negative whole numbers to the set of positive whole numbers, or to the set of whole numbers in general, you come up with a set known as the set of integers. So this is what we have. Okay, let us now look at what are known as rational numbers. So I think we also do rational numbers tonight. I think that's where we're going to start from. Yeah, so rational numbers, this is just a set that, this is a set of numbers that can be expressed in a fraction form. So these numbers can either be negative or positive, as long as you are able to express them in the fraction form, or in the form a over b, where a and B are what? Are members of integers. And B should never be equal to 0. So that is a set that we're calling the set of what? Rational numbers. So for any number to be called a rational number, it should be able to be expressed in the form A over B, where A and B are what? Are members of integers. And B is not supposed to equal to 0. Yeah, so this is what we call rational numbers. So we are going to see how we can express certain decimal numbers into fractions. So that is where that topic comes in. So I'm sure you are all able to understand what I'm teaching. So in case you have any questions, feel free to interrupt as I'm teaching. Okay, so what are real numbers? So before we talk about real numbers, let me also tell you to say, apart from rational numbers, we also have another set which is known as a set of what? Irrational numbers. So these are some of the examples of rational numbers. But when we talk about irrational numbers, so irrational numbers are simply just the opposite of rational numbers. So the opposite of rational numbers, the opposite of rational numbers, we call them irrational numbers. So in other ways, or by definition, irrational numbers are simply just numbers that cannot be expressed in the form A over B. And you may ask yourself, which numbers are those? So a number that cannot be expressed in this form, we have pi. You can't express pi in the form A over B. And then apart from that, you can also express the square root of 2 in the form A over B. You can't express the square root of 3 in the form A over B. You can't express the square root of 5 in the form A over B. You can't express the square root of 1 plus the root of 3 in the form of A over B. You can't express the root of 3 plus the root of 2 in the form of A over B. So all these numbers that I've written here are examples of what? Irrational numbers. So numbers that cannot be expressed in the fraction form are known as irrational numbers. So this is what you have to understand. So now there's also another special set that is formed by adding rational numbers and irrational numbers. So when you add rational numbers and irrational numbers, you form a set that is known as the set of what? Real numbers. So when you add this set and that set, the answer that you get is the set of what? Real numbers. So this is what we're going to discuss on the next page. So real numbers are also called measuring numbers or measurement numbers. This includes all numbers that can be written as decimal. A real number is a number which can be represented by an infinite decimal expansion. So this is these are some of the examples of real numbers. So when you check 1 over 2, we can express 0.5 in the fraction form, which can be written as 1 over 2. So this tells us to say this one is what? Is a rational number, because you can express it in a fraction form, but you can't express pi in a fraction form, meaning this is an irrational number. And then 10 can also be expressed in the fraction form, meaning it's a rational number. So whenever you add the set of rational and irrational numbers, you get another set which we call the set of real numbers. Okay, so we have some real numbers that have repeating decimal parts, and some of the real numbers have terminating decimal parts. Yeah, so when we talk about repeating decimal parts, we talk about numbers like this one there or this one. So now there is a way, or sometimes you may be asked to find or to express this number into a fraction, or to express this repeating rational number into a fraction. And how do you express that, or how do you express it into a fraction rather? So we are going to see how to do that. So Okay. So I talked about rational numbers. So now let us talk about them in details. So a rational number, like I said, it's a number that can be expressed in the form a over b. But in this form, you need to understand that this a and b should be what? They should all be integers. That's why I'm putting this symbol, member of what? Integers. So this one, integers, not real numbers. Integers. So this A and B should be members. Both A and B should be members of integers. And then B should never be equal to 0. And then the other thing that you need to understand is that A and B should be what? Should be co-prime factors. So what do we mean when we say co-prime factors? So co-prime factors, this simply means that A and B, or this fraction is in its lowest form, meaning there shouldn't be any number that can go into A and also into B. That's what it means. Meaning the fraction is in its lowest form. Okay. So we also have another set of rational numbers. Yeah, so we have another set of rational numbers which repeat. So this can be expressed in a fraction form, but when written in its decimal form, it has numbers that repeat. So now, how do we deal with such numbers, or what are examples? So these are some of the examples of rational numbers that repeat. So we can see here that 1 and 2 are repeating. That's the reason why you can see this bar on the next part there, on top of 1 and 2. So in this other example, we've seen that 5 is repeating there. Of course, there's supposed to be 3 dots there. So 5 is repeating, and hence we have to put a bar on 5 there. So from here, I'm sure I'm going to show you how you can change these repeating numbers to you can change these repeating numbers to fraction forms. How do you prove that this is a rational number? Because we said a rational number should be able to be expressed in this form, which is a fraction form. Now, how do you prove that you can express this in this form? It's very simple. I'm going to show you. Okay, we also have another set of rational numbers which we call terminating rational numbers. So terminating rational numbers are numbers like, for instance, 1 over 2. 1 over 2 is 0.5. So 1 over 2 is 0.5. So we don't have anything that is repeating this side, and hence this one has been terminated, meaning it ends just here. So terminating rational numbers are just the opposite of repeating rational numbers, meaning they don't have anything that is repeating. So some of the examples are 1 over 2. So 1 over 2 is one of the examples. All right, so let's see how we can deal with these questions. So we have these questions which are saying, in the following problems, find the form A over B of the given decimal expansions. And we have been given 3.2 bar. So what this means, if you have 3.2 bar, this means that this 2 is repeating here. So when 2 is repeating there, this can also be written as what? 3.222222. You have a lot of 2's this side repeating. So that's what it means. Now, how can you express it in the form A over B? Or the other way they can ask this question is that prove that 3.2 bar is a rational number, meaning you have to prove that it can be expressed in this form. How do you prove, or how do you show it? Very simple. So the first step, we say let me write it down. So the first step, we're going to say let the given number there be equal to x. So you're going to have 3.2 bar being equal to x. And then from there, the other thing that you're going to do is we have to make sure that this point moves and covers at least one set. Okay, let me not say at least, let me just say this point should cover one set of the repeating numbers. So sometimes you can have 3 repeating numbers or 2 repeating numbers, like the second case there, but we're going to go there first. So let's see how you deal with such what's this, a case. So you have this question there, and it says x is equal to 3.2 bar. So how do you do that? So we have to move this point to cover one repeating number there. So to cover a set of repeating numbers. So in this case, we only have 2 repeating, and hence we only have to move once or one step to cover this repeating number. What this means is that we are supposed to multiply the given equation, or rather the equation that we have made here, by 10, because we know that if we multiply it by 10, that's when the if we multiply this by 10, that's when this point will move one step going that side. So if I multiply 10 times x, I'm going to get 10x. So 10x will be equal to, if I multiply 10 times 3.2 bar, I'm going to get 32 point. This 2 is repeating, so it will still be there. And then from there, what we need to do is to subtract this equation from this equation. So we are going to say 10x minus this x there. And then we say this is equal to 32.2 bar. We have 32.2 bar minus 3.2 bar. So when you do the subtraction there, you discover that 10x minus x, this one will give you what? 9x. And this is going to be equal to 32.2 bar minus 3.2 bar. Is just the same as subtracting 32 minus 3, because you know that 32.2 bar, if you're subtracting decimals, you have to make sure that the decimal point is in the same line there. So you have something like this. So when you do the subtraction, this and that to subtract, you get a 0. So 32 minus 3, that will give you a 29. So we divide by 9, we divide by 9. So the value of x becomes 29 over 9. So if you try to put this on the calculator, you discover that the answer that you get will be 3.22222 to continue going like that. So we have expressed 3.2 bar in the form 29 over b. Therefore, the final answer will therefore be equal to, you just have to say 3.2 bar is therefore equal to 29 over 9. So let's see how we can solve the second question there. So there are a lot of questions that I've solved on YouTube about this same part here of repeating numbers. So I'm going to forward this recorded session to the group after the lesson. Then apart from that, I'll also have to forward those same questions for practice sake. Yeah, so we have the second part there. So the first step, we say let we are on B, let 3.12 bar be equal to what? Be equal to x. Or let me say let x be equal to that. It's still going to give us the same answer. So I have let x be equal to 3.12 bar. So this bar is on both 1 and 2. So from there, the next thing that we do is to make sure that this point moves moves in such a way that it covers the repeating numbers. So how many repeating numbers do we have this side? We have 2. So if we have 2 repeating numbers, it means that we're multiplying the whole equation by 100. This one, we had 1 repeating number, that's why we multiplied by 10. Here we have 2 repeating numbers, hence we're multiplying it by 100. So we say 100 times x is equal to 3.12 bar. So when you do the multiplication there, you get this side, you're going to get 100x, then this other side you get 300 and what? And 12.12, because these 1 and 2 are repeating. So even after multiplying, it's still supposed to be there. So from there, we now subtract this equation from this equation. So we're going to have 100x minus x being equal to, we have 300 and what? 12.12 bar minus 3.12 bar. So when you subtract this side, you're going to get 99x. Then this other side will give you 312.12 bar minus 3.12 bar. So this 1, 2, and that 1, 2 will give you what? A 0. Then we write a point there. Then 1, we get 1 from 1 there. We put it to 2. So this will be 12 minus 3. The answer will be what? 9. Then here we're remaining with 0. So we put 0 there. So we have 309. So we're going to put 309 there. And then we divide everything by 99. Divide everything by 99. And the value of x becomes so we have to reduce this to its lowest term. So we know to say 3 can go into 3. How many times? 1. 3 can go into 0, 0 times. 3 can go into 9, 3 times. And then 3 can go into 9, 3 times. And 3 can go into that other 9, 3 times. So if there is a number that can go into 103 and 33, you can simply divide it further to make sure that the answer that you have is in its lowest term. Right, so the value of 3.12 bar is therefore equal to 103 over 33.
Just a moment, sir.
Yes, sir.
I have
Okay, you can unmute yourself.
it's nothing. Are
Okay.
you able to hear me?
Yes.
I have a question. Starting from where we subtracted 1 from 100,
Okay.
and the other side is. So why did we subtract x from 100? How did that come about? Could you just repeat it for us?
Okay. Okay. Thank you for that question. In other words, you are saying, why didn't we subtract x from 100? Instead, we subtracted 100. I mean, why didn't your question means why didn't we subtract 100 from x? Instead, we subtracted x from 100. Is that what you mean?
No,
Mm.
I'm a bit puzzled as to how this all happened. Because from before we reached that stage, we were at 100 x is equals to 312.12. Then the next step was 100 x minus x. How that happened? Where the x that we subtracted came about, or where it came from.
Okay,
Understand?
so one thing I'll just tell you is that this is just like a method that works in order for you to convert these decimals to fractions. Yeah, and these are the steps that you're supposed to follow. And that's why I'm saying I'll give you some questions that I solved on YouTube where you have to which you are supposed to go through in order for you to understand more about this, because there are some questions that are not only like this. You find a question, let's say maybe 3.5, and then the repeating numbers are somewhere this side. So how do you deal with that? How do you deal with that question? It's a bit different from the way you deal with this question. So they are all in the recorded sessions that I'm going to send you. Yeah, so this is just a method that you have to know. Yeah, so sometimes if knowing is, if you find a challenge in knowing something, it's better you master it. Then when you master it, the same mastering will mature to knowing at one point. So yeah, I think that's the advice I can give at the moment. Yeah, so this is just a method. These are just some of the steps that you need to follow in order for you to convert that to a fraction. Okay.
Hello, sir.
Yes.
Yeah, I come across sometimes they multiply both the maybe one equation is multiplied by 10, the other one is 100. Which situation brings that?
Um, okay, it's I think it's this situation, but That's not how I explain it. I always explain, even this one, I'll explain it to you in the same way I've explained this, except that the first step that you need uh, to take is to first make sure that this point moves closer to the repeating numbers. Then from there, you have to multiply it further to come and cover the repeating numbers, meaning the first step you multiply by 10. After multiplying by 10, the second step you have to multiply by 3, rather by 1000, because we have 3 repeating numbers this side. So I think let me try to see if I have any questions that we can solve on that.
Okay, that's clear now.
This one here. So we have this question there. So now how do we convert this to a fraction? So we know that 5 is repeating. And the first thing that we're going to do is to let x be equal to what? 3.145 bar, because 5 is repeating there. So the first step that we're going to do is to make sure that this point moves to that point where it becomes closer to the repeating numbers. So how do you move that point to that point? It's by multiplying by 100, because we have two numbers here that it's going to skip. So if we have two numbers, it means that we're multiplying by 100. So the first step, we multiply by 100. So we have 100x this side, and then this other side, when we multiply this part by 100, we're going to get 300 and what? 14.5 bar. So the next step here is to multiply the whole equation again by a number that will make this point to move and cover the repeating numbers. So this means we're going to multiply it by what? By 10. So this side, we're going to multiply 100 by 10, we'll get 1000. So when this link ends, make sure that you join using the same link so that we proceed. And then this other side, we're going to have 3145.5 bar. So from here, what you just need to do is to subtract this equation